So we begin with the thematic session, which we gave the very generic name, laterality cognition in humans. And our first speaker is Nic. Take it away, Nic.
All right. Thank you for having me. I just want to start by, as is tradition in our country, to acknowledge the local people who have been looking after our land for, I don't know, 60 or 70,000 years. This is a Whadjuk and Noongar people that are the custodians of our land in Western Australia, where I am at the moment. So this is a presentation that's related to Josie Quinn Conroy's PhD thesis. When we put this together, it's a systematic review looking at whether or not there's cognitive benefit to having a typical pattern of verbal and non-verbal cerebral asymmetries. And I will talk you through what we've done. I guess initially the question is why, and maybe this audience doesn't need too much background, but when I tell people about this, I always like to talk about chickens. And the work that demonstrates that a typically lateralized chicken, or at least a lateralized chicken, has benefits to pecking grains when one eye and one hemisphere is looking at the ground versus, and the other eye, the other hemisphere, is looking at the sky to look for predators. And so there seems to be some evolutionary advantage, at least in birds. And if it's maintained itself, or that evolution has stuck around in humans as well, maybe there's some benefit that will be interesting to see. And maybe if we can find it, we could take advantage of it in some way. So the patterns that I'll be talking about are this typical pattern. So we've got the verbal information processing in the left hemisphere and non-verbal in the right hemisphere. So that's what, I don't know, 70 to 90% of humans tend to have. But we also observe atypical patterns. So this might be a reverse pattern, which is an exact mirror of that typical brain. But there are a few other variations. Sometimes we see a crowded pattern such that verbal and non-verbal processing is handled by one side of the brain and not the other. We also see bilateral or symmetrical presentations where neither side is specialized and both sides seem to be involved in both processes. And we also have our mixed lateralization, where one of those functions is specialized, but the other one is bilateral. And so there's a bit of variability in there. And in this presentation, we'll just be comparing the typical against a number of databases, looking for papers that studied language or verbal information processing. Reading was also part of that. And we looked for papers that also did spatial, so they had to do both of those things. And laterality papers were limited to things we could read in the English language. The key inclusion or exclusion criteria was that we wanted to have a neurophysiological measurement of cerebral asymmetry or a behavioral proxy, but we didn't accept handedness as a proxy. So they could have a visual half field or a dichotic listening task. Dichotic listening tasks are amazing, by the way. And in the second criteria was that we needed to have some estimate of cognitive ability. It could be language, working memory, or spatial attention, or something of that nature. The third one is that they needed to link that behavior with patterns of laterality, and we needed to have healthy participants, so no one with brain damage or epilepsy. Here is where we started in terms of our search, and 16,000 papers to begin with, and a few more from Gray literature and other searches. And then there was a bunch of those were duplicates. And then we excluded many of them, most of them, nearly heaps, nearly 8,000, part of the screening. When we looked through them, through the abstracts, and we looked at the full text for 180. got rid of a bunch more papers. We ended up with 15 studies included. These are the studies that we looked at, and you may have come across some of these before, and you may have authored some of these. Many of the studies used functional magnetic resonance imaging. A number of them use functional transcranial Doppler ultrasound. And the remainder used behavioral tasks of some description. We've got some visual half field sorts of paradigms, dichotic listening buzz, so some finger tapping interference. What have we got? In terms of the tasks, most of the people are using word generation. So this is a word fluency task where a letter is presented on the screen. You generate as many words as you can. And for the visuospatial, they've got a landmark task. So a vertical line is to the left or right, to the center of a horizontal line. You have to make a judgment about that. The other things we've got here, we've got an animation description task. This is where a video is played and you have to produce some words to describe that. The visuospatial memory task, this is Gron et al. Is looking at where some rabbits are hiding in a hole. This was done with children. You just have to remember where those rabbits were from an array of dots essentially on the screen. I've got the lexical decision task, word, non-word judgments. This is Marco's work, and distorted faces, whether or not the face is a regular face or it's got some sort of blur applied to it. Chi and Kaplan had a word encoding, so they had to see words on a screen and decide whether it was a living or non-living object. And the face encoding, again, just looking at faces and deciding whether or not they were happy or sad. We've got some reading aloud down here in the Stellan articles versus a line orientation task. So given a line of a certain orientation, have to say which one it matches. It's a Benton line orientation task. And the final one looked at memory for words in a fairly simple paradigm. And they had to make judgments in terms of word versus non-words, and the dot enumeration just have to decide how many dots are on the screen at any time. So one of the things that we think might be important is whether or not the task allowed you, or the paradigm or the experiment allowed you to have bilaterality represented. And that was the case for many of the studies, but not all of them. We'll talk about that a little bit later. What else have we got? So in terms of the patterns, just to give you a rough overview of what's there, some of these samples are a bit more selective than others. For example, Robin's study here, we've got 50% of people who are typical and the other half are atypical, right? So this is not what you'd expect if you had a normal sample. This was a left-handed bias sample. And this Filati study has a little bit more variability in it, but also this is a study that I was involved with. We used functional transcranial Doppler ultrasound and a slightly different way of calculating the laterality index compared to some of the earlier work in this. I can talk about that if you'd like. Anyway, so there's a fair bit of variability in there, but we have atypicality reflected. And these are the makeups of those groups. So not massive samples of atypical individuals, but it is there nonetheless. What did we find? Well, first of all, we categorized the cognitive tasks into verbal, non-verbal, or both. And so usually that was a dual task. And for each comparison, we calculated a valence, and this is just whether or not there was a difference in what direction it was. So if it was typical, we gave it a positive one. If there was no difference, we gave it a 0. And if it was atypical advantage, we gave it a -1. This is like a poor man's meta-analysis, essentially. Again, this is just based on statistical significance. So when available, we extracted, calculated an effect size. So we've used Cohen's D. This is a summary of all the comparisons that we found in these papers. So predominantly typical versus crowded, but some of the other combinations are reflected as well. So if we first look at these valence results, what we see is a few case studies, and we don't find a massive amount going on there, but it is showing that on average, this is an advantage of being typically lateralized relative to normative data. In terms of the group studies, we see that it looks like when you're doing the dual tasks, on average, the weight is coming out saying there's an advantage of being typically lateralized. Non-verbal, not very convincing, and verbal, again, it looks like there's an advantage there. All right, and so the reason for these big numbers, for example, 77 when we've only got 15 studies. All right, if we look at effect size, just taking the average of effect size, not doing anything fancy yet, we see it looks like an advantage in all of these instances, but not too massive. Most compelling in the verbal, where we've got more information, so we've got less error there. So I just want to break that down for you into a series of meta-analyses. If we look at both, when we've got non-verbal and verbal tasks done simultaneously, the overall effect size of that big diamond here, this is a forest plot, so we can see an effect size estimate for each of the tasks included. That's coming out as overlapping with 0, so we'd be happy to say there's not too much happening. For non-verbal tasks, very similar story, so really not too much to write home about. For verbal tasks, it gets a little bit more interesting. We've got a lot more information. Not too many studies represented here. We've got the work from Magritte-Gouin, Robin Gerritz, Stellan, Bellardi, done a lot of comparisons. We've got a Hernstein paper here, back from 2008, the good old days. And we do see a significant effect size here in favor of the typical lateralization, an advantage of being typically lateralized. So let's just break that down a little bit further so we can further separate our verbal tasks into language. And as an advantage here, it's not one way or the other. But when we get to reading, this is biased by some quite large effects in this behavioral work by Stellan. But on average, when you add all these up, we do see a significant effect here. So it looks like there's an advantage of having a typically lateralized brain when it comes to reading. So that's the results, and here is a conclusion. And to answer this question, is there a cognitive benefit for typical pattern of verbal and non-verbal cerebral asymmetry? Overall, we'd say, yeah, yes, there is for verbal information processing, particularly reading. No advantage for non-verbal information processing. But just in terms of a few reflections on what we found, if we dig a little bit deeper into the data that's not reflected in the meta-analysis, we don't have great representation of the atypical patterns in this sample of studies, right? And so, again, age-old sort of, I guess, call is we need to increase our representation of these alternate patterns. There does seem to be an advantage, or it seems perhaps a better approach to consider bilaterality, or symmetries, that should be. So, for example, doing more continuous sorts of analyses, for example, regression or linear mixed modeling, rather than breaking people down into groups and doing sort of analysis of variance comparisons. That seems to have a slightly different impact, but because we've got so many different studies here, all using different techniques, it's difficult to reconcile. So again, some consistency in what we do would be great. But one other call would be to make sure we are estimating behavior which is independent of our laterality tasks. So many of the studies, the behavior that we got was based on the number of words generated, for example, in word fluency, or the accuracy of the landmark judgments. It seems to be a better reflection of what's going on, maybe a clearer relationship when you actually do an independent psychometric assessment. So experience coming in sort of cold to this group a number of years ago was I didn't know many people, but I quickly felt part of the family. So I'm pleased to be joining you online. I would love to be joining you in person, maybe one day. So thank you.
You hear the thunderous applause, maybe.
Is that what that was?
Are there any questions? Yes. Yeah, but so Nic can hear us out, but we cannot hear the microphone. Hi, Nic.
I can't hear you very well.
Can you hear me?
Yes, I can hear you now.
Okay, that's great. Thank you. Very interesting. I was wondering, the main effect in the reading data seems to be driven a lot by the study from '87. Have you looked into the risk of bias analysis for the different studies? Because I would always be a bit skeptical if there's just like one very old study that seems to be a huge outlier in my meta-analysis. So maybe these newer techniques to look at whether how high the danger of the bias in a specific study is might be helpful in judging whether this is a true effect or that might be something that's just driven by a smaller study from long ago.
Yep. Yeah. So we have looked at bias. I haven't got that data to show you as part of this. There's actually 86 and 87, the same group did two studies. Been replicated in the sense that no one's attempted to, as far as we can find, and so that is something that we're toying with doing here as well. But I completely agree. Yeah, if it's one lab finding this thing, that is going to be muddying the waters or driving the effect. So yeah.
Thank you.
Hi, Nic. I have a question. Did you come across any ingenious dual task setup that have no interfering, let's say, use of hands or anything like that? Because from my own work, it's hard to really know in a dual task what we're actually measuring, because it's not the output of language that we can do, hands-free, but always the other tasks, we need to use a different input method. I was just wondering, in your literature search, did you come across some ingenious solution to that?
There wasn't. I guess most of the dual task work we'd come across before, so I don't think there's anything there that surprised us. But now that you've asked the question, I will go and have another look and see if there's any better way to do it. So yeah, I don't have a good answer for you, I'm afraid.
Thank you anyway. I understand. Thank you very much.
Oh, sorry, I can't hear you very well at all.
Is it better? Can you hear me louder than maybe I ask
it's a little better. I wonder if I can turn. I can't find a way to turn.
And then maybe so on the issue of heterogeneity, I was curious to know if the reading or verbal tasks were comparable across studies, or perhaps they use different tests to measure reading ability and verbal.
Sorry, I didn't pick up enough of that to answer. I'm going to try and modify my sound.
So the question was there some like reading and the verbal task, was it very similar or was there a systematic difference there?
Sorry, could you try again?
I'll send an email.
Yes. Can you hear me now, Nick? Okay, I think we need to leave it at that then. Okay, thank you very much, Nick, if you can hear us. Thank you.
I can hear you clearly. Cool, thank you.
Bye-bye.
Could I also ask something?
Yes.
Don't know. Yes.
Just the two of us.
You can shoot it to me in the chat. I don't know. We probably need to move on to the next talk. I'm not sure what's happening.
If it's a quick one, it's fine.
Yes.
Go ahead.
Can you hear me?
Yeah.
Yep.
First, let me say that I think that the previous question was whether the reading and verbal tasks are similar. Is that correct?
Yes.
Okay, so that was the question, Nick, and then I'll ask my question.
So I guess similar in what nature, like phonological or yeah, there was a range of different tasks.
Okay, so that was not my question, but I was also I also found this finding about reading quite interesting, and it's even more interesting because reading is such it's very recent, like evolutionary in an evolutionary term. So why would our brains be like made to favor reading? Why would laterality have evolved so that we can read better? So I'm also skeptical. I would agree with Sebastian that it would be good to do an analysis excluding that study. But if the effect does hold up, then I guess maybe we could explain it in terms of like maybe scanning the environment for detail instead of reading or something like that. I'm one of those people that don't ask a question, but just say what they think in the conference. So.
Yeah, well, I guess one of my working hypotheses is that perhaps what we've evolved to do is to basically meet people and label them. You know, so in that sense, we need to remember names, and we need to remember a face to go with it. And so these tasks that involve both of those processes, not necessarily dual tasking, switching between two things, but actually requiring both of those things to be integrated into one, which is what happens a lot in reading, right? Maybe the case.
Yeah.
Maybe Stan de Haan's got some ideas about that as well.
Thank you.